Hi guys, today we're going to talk about dimensional analysis, and really that's just a fancy term for converting units. And the I can statement we're working on is I can compare two different proportional relationships represented in different ways. And in this case it's going to be different units. So let's start off by looking at a problem. There are 15 kids at a birthday party. Each kid is going to eat 4 slices of pizza. There are 12 slices in each pizza. How many pizzas do I need to order? Well, there's several things we need to consider when we begin solving this problem. First of all, this problem can be solved in a variety of ways. So the way I show you isn't going to be the only way, and you might find other methods that work for you. If you do, please plan to share them in class tomorrow. One possible method is called dimensional analysis, and that's the method we're looking into today. This is just a fancy way of saying change the units. So when we're using dimensional analysis, we multiply ratios together in such a way that the units end up getting canceled out. For example, if I have a fraction, 2/4, for example. If I wanted to simplify this, which is basically what we're going to be doing when we're using dimensional analysis, I'm going to eliminate or cancel out a common factor. And with 2 and 4, a common factor is 2. So 2 goes into 2 once, 2 goes into 4 twice. I can think of it like this as well. 1 times 2 over 2 times 2. Now in this case, I'm going to cancel out these 2's. I'm going to do the same thing when I'm dealing with dimensional analysis, except instead of canceling out numbers, I'm going to cancel out units that are common in the numerator and denominator. Let's keep going. So when I want to solve this problem, I want to start by asking myself, what do I want my answer to look like? Well, I'm looking for how many pizzas I need to order so that every kid at the party gets the 4 pieces or slices that they want. So my question I'm going to ask myself really is, how many pizzas do I need for this one party I'm having? Because I want to end up with pizzas in the numerator and party in the denominator, I'm going to begin with a ratio that has pizza in the numerator, because that makes sense. What do I know about pizzas? Well, I know that one pizza has 12 slices. And so pizza's in the numerator, so we're good. Now I need to find a way to get party in the denominator. My next ratio must have slices in the numerator because I don't want slices in my final answer. So I need to find a way to eliminate slices. So let's do it by putting it in the numerator, because I know if I have something common in the numerator and denominator, I'll eventually be able to cancel it out. I know that there are 4 slices for every one person at the party. This is going to help me eliminate slices. But now I have person in the denominator, and I don't want person in the denominator. I want party in the denominator. So my next ratio has to have persons in the numerator so I can get rid of that. Well, I know that there are going to be 15 persons or people at my one party. Now I've got persons in the numerator and denominator, so I'll be able to cancel it out. All I need to do now is simplify. To simplify this is to multiply my numerators, then multiply my denominators, just like I multiply fractions. So, I'm going to notice there are several units that I can cancel out. Remember, if I have it in the numerator and the denominator, I can cancel it out as long as they're paired up. So, notice, I can cancel out this unit of slices with this unit of slices because they're common. It's a common unit. I can also cancel out persons because that's common to the numerator and denominator. And once I do that, all I need to do is multiply the numerators and then multiply the denominators to get 60 pizzas for 12 parties. but I don't want to know how many pizzas I need for 12 parties. So I'm going to simplify so that I get 1 in the denominator, because I only want to know how many pizzas I need for my 1 party. And when I do that, I divide the numerator and denominator by 12. That gives me 5 pizzas for my 1 party. Let's look at another example. How many minutes are in a year? Now remember, there are several ways that you can answer this, but I might want to start by asking myself, what do I want my answer to look like? What unit do I want in the numerator? What unit do I want in the denominator? Well, I'm comparing minutes and years, so I need to know how many minutes are in 1 year. So in the end, I need to have minutes in the numerator and year in the denominator. So let's start with a ratio we are familiar with. And this one puts minutes in the numerator, which is good because that's what I'm looking for. 60 minutes is the same as 1 hour. So my next ratio has to have hours in the numerator because, remember, I want my ratio to be comparing minutes to year. And so I can't have hours in there. It's not one of the units I'm concerned with. But for this problem, I need to eliminate the hours so that I can get the ratio I want. So let's think of another ratio that has hours. I can put hours in the numerator. That's going to help get me to how many minutes are in a year. And I'm going to do that by saying, well, I know there are 24 hours in 1 day. This will help me get rid of the hours, but now I've got days in the denominator, and I don't want them there. So I need to find another ratio that puts days in the numerator and helps get me closer to finding out how many minutes are in 1 year. Well, I know that there are 365 days in 1 year. And this is great because I have years now in the denominator and minutes in the numerator. So my next step is going to be to eliminate or simplify by crossing out what I have common to the numerator and denominator so that I can multiply my 3 ratios. So I can cancel out hours because I've got hours in the denominator, hours in the numerator. And I can cancel out days because I've got the unit in the denominator and the numerator, which is good because it leaves me with minutes in the numerator and year in the denominator. Now that I've canceled out my units, I simply multiply all the numerators and then multiply all the denominators to get 525,600 minutes in 1 year. Now I don't need to simplify here because my goal was to figure out how many minutes are in 1 year, and I have that in my denominator. Let's look at another example. Your car is traveling at a rate of 50 miles per hour. What is the rate in feet per second? Now in this problem, the information I've been given doesn't give me either feet or second. So I'm going to have to do a little more dimensional analysis to get rid of those excess units. What I am given is, well, let's ask ourselves, what do we want our answer to look like? We want to know how many feet are in 1 second or per 1 second while I'm traveling in my car. But I'm given miles per hour. So my first ratio is going to have to get rid of those miles per hour. So this example is different from the previous one because we're converting both the numerator and the denominator, but we can do this. So I was given miles per hour, 50 miles in 1 hour. Now I need to figure out how to get rid of hours, so I got to get that in the numerator. Well, I know there's for every 1 hour, there's 60 minutes. Now minutes, this is helping to get me a little closer to seconds. But I don't want to know how many minutes. I don't want to know my rate in terms of minutes, so I need to get rid of minutes. So I need to get it in the numerator. Well, I know 1 minute is the same as 60 seconds. So now you see I've eliminated hours and minutes. The last ratio has to get miles in the denominator because I still have to deal with this unit, which is not important to my answer. But I do know how many feet are in 1 mile. This is helpful because now I've got miles in the numerator, miles in the denominator. I can cancel them out. I already have seconds in the denominator, which is good because that's what I'm looking for. And I have feet in the numerator, which is great because that's the other unit I need to have in my answer. I'm going to multiply all of these units, or all of these ratios. But first, I'm going to cancel out my common units. I can cancel out miles, I can cancel out hours, and I can cancel out minutes because I have one in the numerator and one in the denominator for each of those units. Now I simply multiply the numerators and multiply the denominators, which gives me 264,000 feet in 3,600 seconds. And again, I don't want to know how many feet in 3,600 seconds. I want to know how many feet in 1 second. So I'm going to need to simplify my answer. And when I do that, I divide the numerator and the denominator by 3,600, just like when I'm finding unit rates. And that gives me 73.3 repeated feet for every 1 second, or 73 1/3 feet per second. And it doesn't matter if you put your answer in decimal form or in fraction form. So let's talk about this hermit crab. He moves at a rate of 6 inches per minute. So the question is, what is its speed in miles per hour? Again, I'm not given any units that are going to be useful for my answer. So I need to start by asking myself, what do I want my answer to look like? Well, I'm trying to figure out how many miles in 1 hour. Now notice in all of these, I have 1 in the denominator. So in all of these problems, I'm actually looking for a unit rate. So I'm going to start with my given ratio, 8 inches in 1 minute. Since I've got minutes in the denominator, I need to somehow get minutes in the numerator. Well, I know that there are 60 minutes in 1 hour. Now I'm just using all of these conversions that I already am familiar with from years and years of math. But now that I have hours in the denominator, I need to now figure out how to get rid of that inches and turn that into miles. So let's get inches in the denominator. 1 foot equals 12 inches. That's a conversion I'm familiar with. But now it puts foot in the numerator, and I don't want foot in the numerator. So I need to get rid of that by saying 1 mile equals 5,280 feet. And you guessed it, I need to multiply these and cancel out the units that are not useful to my problem or that I have in common in the numerator and denominator. Then I can multiply all the numerators and multiply the denominators, and you guessed it again, I'm going to need to find a unit rate. So I simplify my answer by dividing the numerator and denominator by 63,360. And that gives me 75 10,000ths, and that's all being repeated, miles per hour. And that's not very fast. Now it's your turn. I'm going to give you 2 different slides. So pause the video when you get to the next one. Work out the problems in your work section of your WSQ. Then go ahead and continue and work out the problems on the second slide. You may use a calculator to help you, but please show all work and don't forget your summary and question.